Okay, we can start now. Chapter 4, Addressing Modes. In this lecture, we will talk about the assembly programming language to get machine codes to any microcontroller. Assembly is a low-level programming language between machine language and high-level languages. The function of each command used in the assembly is expressed by the abbreviation of the English of it. So we can easily understand the codes. For example, move ACC, $, 53 hex. It is the abbreviation of the move. So we will do a transfer operation with this command. What is the operation for it? If you see the number near the diasis sign is a data. Okay, this data is transferred to the accumulator. Or we can give another example with the DJ and Z. It is the decrement and jump if not 0. This command is decrease the ACC value by 1, and then if it is not equal to 0, the program will branch to the X1 label. DJ and Z, decrement and jump if not 0. First of all, we will decrease the ACC value by 1, and if it is not 0, the program will branch to the X1 label. In order to write program in assembly language, microcontroller hardware must be known in detail. So we will talk about before the structure of the 1851. Now we will talk about the addressing mode for 1851. What is the mean of the addressing mode? Addressing mode refers to the way in which the source and destination are specified in any command. The addressing modes defined for 1851 family are described in detail below using the command move. For example, for the move command, we know that we will do a transfer operation, so we have to have some destination and source because we will do a transfer operation. The transfer will done from the source to the destination. By using the move command, we can do byte and bit level data transfer. We will use this command for the general transfer, and data is transferred from the source to the destination always for the move command. We have 5 types of addressing mode for the 1851. Now we will learn the addressing all types of the addressing modes. The first one is the immediate addressing. With this command, we can write the desired data to the specified address. Source should always be a data. Okay, how can we understand it is data or not? If you see a diasis sign, okay, we can easily understand that the near of the diasis sign is a data. So for the immediate addressing, of course, we have a diasis sign and a data. Okay, for the immediate addressing, again, we have a move command. In here, we have a destination. Destination means it should be a register or accumulator or an address value, but the source should be always a data. In here, as you see, we have a diasis sign. So the near of the diasis sign should be a data. The sign indicates that there is an immediate address. We can easily understand in this way. For example, move a diasis sign data. The data will be transferred to the A. In here, move Rn diasis sign data. The data should be transferred to the Rn. What is mean n? N can be from 0 to 7 number. As we saw before, we have some bank area, and each of them has some register labeled with R0 to R7. Okay, now we talk about these registers. Maybe we can again show this kind of registers. Yes, in here we have a bank area, and each of bank has some registers starting from R0 to R7. Okay, in the command we can use the R0, R1 and that kind of labels or tags. Okay, in here we have another command, move at RI, that is a sign data. Again, as you see, we have a data as a source, and destination now is a pointed address value. At sign shows us it is an address pointed by the RI. Okay, we have an address here, and this address value is pointed by the RI. In here you can see I can be 0 or 1. In here we have our N. It can be 0 to 7, but if you use the registers for the pointed any address value, we can only use the R0 and R1, okay, for this operation. The parenthesis sign shows us the address value. It is 01 hex for the bank 0, but R1 has a value in the memory cell such as 10 hex, for example. After this command, the data should be written to the 10 hex address. Okay, yes, move direct, and that is a sign data. Direct means it can be an address value which is addressable only direct addressing. Okay, how? Yes, in here we said before, for the low RAM area it can be accessible with direct or indirect addressing. In here we have SFR area, and we can easily access this address value with the direct addressing. But in here we have another area, memory area, high 128 bytes memory, and we can only access with the indirect addressing. So if we talk about a direct address and data, this means it can be accessible with the only direct address. Okay, accessible only direct addressing. So this means an address value which is accessible only direct addressing modes. The data will be transferred to the address value. In here we have another command, move DPTR. As you know, DPTR is 16-bit register, 16-bit area, so the data should be 16-bit. Okay, in here we have 16-bit data. This data should be transferred to the DPTR with this command. Okay, we have some examples here. Move A, that is a sign 02 hex. It means we have a data which is 02 hex. This value is transferred to the A. After this command, A value will be 02 hex. It means for the 8-bit register area, 8-bit memory area, 0, 1, 0, 0, 0, 0, 0, and 0. Okay. The first bit of the accumulator will be 1 and the remaining part will be 0 after this command. Another example is move 20 hex, diasis sign 20 hex. 20 hex is a data and this data is transferred to the 20 hex address. Another example is move R0 diasis sign AA hex. This data AA hex is transferred to the R0. But in here we have a difference with another commands. As you see, we have also a 0 here. What's mean? If the number or if the data starts with any letter, we should also write a 0 value. Okay? For example, if the data is 99 hex, we don't need to write a 0 also here. But if the data is start with any letter as A, B, C, D, E or F, we should also write to here a 0. And another value is not important for us. It can be from 0 to F. Okay? So the 0 means as like that. Yes, another command is move dptr diasis sign 1FE7 hex. We don't need to write here a 0. It is not important for us because the operation will always start from the low byte. Okay, so the low byte of this data is E7 and the high byte of this data is 1F. So the 0 is not important for us. You can write or not. It is not important. After this command, 1FE7 data is written to the data pointer. How? The data pointer is 16-bit register consisted of two 8-bit register. The low byte of this is DP low. The high byte of this DP high. So DP low after this command will be E7 and DP high after this command will be 1F. If the numbers start with the letter, we should write a 0 in front of it. But if the number is start with any number, we don't need to write a 0 value in front of it. Yes, in here we have another command. It is move P0 diasis sign 0cc hex. As you see here again, the number starts with a letter which is C here, so we should write a 0 in front of it. After this command, port 0 will be CC hex. What is C means? In the decimal number system, as you know, it is 12, right? So the low byte of it's 1100 hex. Sorry, it is not low byte. The first 4 bit will be 1100 and the high 4 bit will be 1100 again. In here we have a command move 40 hex diasis sign 40 hex. So we know this 40 hex is a data and it is transferred to the 40 hex address. How? In the structure of the 1851 in the RAM, we will do an operation for the 40 hex address. In this address, after this command, as you see, we have 40 hex value. The 40 hex value or 40 hex data is written to the 40 hex address. Another addressing mode is direct addressing. With this method, the data in an address can be written another specified address. Generally, it can be used as like that: move a rn. Rn value is written to the accumulator after this command. We don't have any diasis sign for this addressing mode. Move a data in the specified address is written to the accumulator after this command. Move a data in the accumulator is written to the Rn. Move direct A data in the A is written to the direct address. Move Rn direct, a data in the direct address is written to the Rn. As you see here, n is always 0 to 7. Move direct Rn, a data in Rn register is written to the direct address. Move direct means we have two address value as destination and source, and a data in this address is written to the direct address. We can also use with the ports. In here, for the ports, n can be from 0 to 3, n can be from 0 to 3 because we have 4 ports, which are port 0, port 1, port 2, and port 3. The value in the port n is written to the accumulator. The value in the accumulator is written to the port n. For example, move a R7. A data in R7 is written to the A or accumulator. Which R7? As you know, we have 4 R7 because we have 4 banks. So we can easily say this, the selected bank. Okay, R7 for the selected bank. Move a 02 hex. We have a data in the 02 hex address is written to the A. Here we have two commands. One of them is move a 02 hex. Another of them move a diasis sign 02 hex. There is only difference is diasis sign. If we don't have diasis sign, it should be an address. The data in 02 hex is written to the accumulator, but here the transfer data is already 02 hex. We can easily understand from the diasis sign, 02 hex value is written to the accumulator. So it is important, if the number has diasis sign in front of it, it is a data, otherwise it is an address. Move 30 hex, 40 hex. We have a value in 40 hex address is written to the 30 hex address. Move a 22 hex. We have a data in 22 hex. It will be written to the accumulator. Yes. Move R5 30 hex. We have a data in 30 hex. It will be written to the R5. And move port 2 and A. We have a data in A and it will be written to the port 2. How? As you see here, this part is the accumulator. This is the 0th bit and 7th bit, and this is the port 2.0, 0th bit of the port 2 and 7th bit of the port 2. Each bit in the accumulator is transferred to the related area, as you see. Okay, after this comment. Yes, for the bit-based operation, we can use the move command also, but we have to know this. For the bit-based operation, C can be, or C should be, destination or source. Okay, C should be destination or source. In here, C is a destination. The bit value will be transferred to the C, and for this usage, C is a source. The value in the C will be transferred to the bit address. In the bit addressing, carry bit or C must be either destination or source. The remaining bit can be one of the direct addressable bit. For example, move C ACC.6, the sixth value of the accumulator will be transferred to the carry flag. Or move C port 1.2, the second bit of the port 1, second bit of the port 1 will be transferred to the carry flag. In here we have another usage, as you see. For the accumulator we used before A, but here we used ACC. If you use accumulator for the bit-based operation, we will use ACC, okay? ACC and the related bit. For example, if you do an operation for the second bit of the ACC, we will use ACC.2. We cannot use A.2. Okay, we cannot use. But for the byte-based operation, we can use A. We have a warning here. In RAM, a byte can be transferred to a bit addressable area, but a bit cannot be transferred to a byte addressable area. As you know, we have a bit addressable area from 20 hex to 2fx. We can remember from the, yes, here it is bit addressable area. We can do for this area both bit or byte operation, based operation, but the remaining part of the RAM we cannot do bit based operation. Okay, the warning is about it. Yes, when move A 51 hex command is executed, what will be happen? Yes, in here we have a structure of the 1851. Move A 51 hex. What is the operation? We have a value where in the 51 hex address, this value will be transferred to the accumulator. So in the RAM, what is the value? The related address, we have 3fx value. This value will be transferred to the accumulator. Tomorrow we will start to the lab. For this, please use your computer because we will use a compiler. And please see the appendix 2. In here we have a Microvision development software. We should download the related program in this address. Okay, in this address, please download this program. In this address we have another program, but we will use C51. Okay, for the 1851 based software we will use this icon. Please download the related compiler we will do an application in the lab. Another addressing mode is register indirect addressing. In this addressing mode, we have an address which is pointed by the some registers. For example, move A at Ri. We have an address value which is pointed by Ri. The data in this address will be transferred to the A. The data pointed to the by register Ri is written into the accumulator. If we have this kind of command, the data in the A will be transferred to the address which is pointed by Ri. For example, in this usage, we have already a data as a source. This data is transferred to the address which is pointed by Ri. And also we have another command here. We used first time, move X. X mean comes from the external. The transfer operation will done from the external memory. The address, the data which is pointed by Ri in the external memory is transferred to the accumulator. The data at the external RAM pointed by the register Ri is written into the accumulator. If we have this kind of usage, the data pointed by data pointer in the external memory again, because we have X value here, will be transferred to the accumulator. Again, we have another usage here. The data in the A will be transferred to the address which is pointed by Ri, but of course in external memory again. The data in the A will be transferred to the address which is pointed by data pointer in the external memory. For example, we have a piezo codes example here. The first line is the move 20 hex diasis sign 40 hex. So we know that if we have diasis sign, it is a data. After this command, we will have for the 20 hex address is 40 hex value. Again, we have to say this again. Parenthesis means address, okay, not data. So 20 hex address has 40 hex value. In here we have a piezo codes example. Move 20 hex diasis sign 40 hex. The 40 hex value will be transferred to the 20 hex address. So after this command, we have a 40 hex value for the 20 hex address. Another command is move R0 20 hex. So we have a data where the source is 20 hex. It is an address because we don't have diasis sign. And we know this before this command, we have 40 hex value in the 20 hex address. So after this command, R0 will be 40 hex. The data in the 20 hex address is transferred to the R0. We'll continue now. Move 40 hex diasis sign AB hex. AB hex is a data again because we have diasis sign. This data will be transferred to the 40 hex address. After this command, 40 hex address has AB hex value. Another command is move A at R0. Data in the address pointed by R0 will be transferred to the accumulator. What is the R0 value? Before this command, we have to know this. as you see here, the second line, R0 has 40 hex value. So the data in the 40 hex address will be transferred to the accumulator. We have AB hex value in the 40 hex address. So after this comment, A will be AB hex. In here we have another example, a piece of codes example again. Move PSW diasis sign 00 hex. What is mean? And as you remember, third bit and fourth bit RS0 and RS1. In the program status word, we have bank selecting bits. Bank selecting bits R0, RS0 and RS1. After this command, each cell will be 0, 0, 0, 0, 0, 0. So we can easily say this: if both of the RS0 and RS1 are zeros, so we will select the bank 0. Remember the related part of the lecture notes. Here, if both of the bank selecting bits are zeros, we'll select the bank 0. So if we use any Rn value, it is about the bank 0, not the other of them. And also, please remember that if we do all of the bits are zeros, you will do also carry flag is 0. Okay, the 7th bit of the PSW is carry flag, so the carry flag will also be 0. Okay, now bank 0 is selected. Move R1 diasis sign 30 hex. It means R1 will be 30 hex. Move 30 hex diasis sign 20 hex. It means 30 hex address will have 20 hex value after this comment. Now move 40 hex at R1. The data in the address pointed by R1. What is the R1 value? 30 hex. The data is in this address 20 hex. So 20 hex value will be transferred to the 40 hex address. The data in the address pointed by R1 will be transferred to the 40 hex. Before this comment, R1 is 30 hex and the data in this address 20 hex. 20 hex will be transferred to the 40 hex address. 4.3 is register addressing. Move Rn destination or source Rn. In this usage, we have to know this: destination or source should be register, but not at the same time, both of them. For example, move R0 A. The data in the A will be transferred to the R0. Move B R2. The data in the R2 will be transferred to the B register. Move A R5. The data in the R5 will be transferred to the A, but we don't use both destination and or source register. For example, move R4 R7. We cannot use that kind of command. How can we do this operation? For example, before this command we know this: bank 0 is selected and we want to do a transfer operation from R7 to R4. How can we do it? we can do this operation with only one comment. Okay, how can we do this operation with only one comment? Please remember the memory. We said bank 0 is selected. So if the bank 0 is selected, what is the operation? R7 to R4, yes. We want to transfer the data in the R7 to the R4. And the R4 has 04 hex address. And R7 is 07 hex address. So we can easily do this operation by using the byte addresses. Okay, move 04 hex 07 hex. That's all. Or we can do the same operation by using R4 07 hex. Or we can do the same operation 04 hex R7. Okay, but we cannot use move R4 to R7.